Hi guys, welcome to DevTalk with FK, and in this video we're going to be running through the backend developer roadmap. In the previous video we looked at the front-end developer roadmap, and like I said, when I was planning to make these videos, I first wanted to design my own roadmap, but then I saw these awesome roadmaps on roadmap.sh. These guys are amazing. They have roadmaps for a whole lot of tech parts, and I'm also going to be going through their backend developer roadmap just as I did with the front-end developer roadmap and be giving my own opinions. They have their own opinions, and I'll most likely be agreeing with them most of the time because they have done such a very great job. But I'm also going to be giving my own opinions from my own experience. So let's get started with the backend developer roadmap. So let's begin. Before we start, if you're looking for the front-end developer roadmap, you can check out this link here for the front-end developer roadmap, but we're all here for the backend developer roadmap, so let's jump right in. Now, to begin, first I'm going to go through their key here. This is some sort of a legend. This is to show us what is their personal recommendation. Anything that is in this purple tick is a personal recommendation by the roadmap.sh team. Then this green one is an alternative to, let's say, the list 3 or 4 technologies. The purple one is the recommended. The ones marked in green are the ones that are alternatives to that. So for example, let's say Angular, Vue, and React is given the purple tick. That means they recommend React, and Angular and Vue are alternatives. There's also this gray check mark, which shows that the order is not strict and the fact that you can learn this particular technology anytime. So you don't need to see this as a blocker to the steps in the learning part. And stuff that are colored gray without a check mark, those ones they won't recommend. They're telling you to skip it. Don't waste your time with this technology, or don't waste your time with this concept. Just move on. So let us begin. The very first thing on the backend roadmap is the internet. As a backend developer, you're going to be creating internet-based applications. So you want to learn how the internet works. You want to really understand how the internet works. And a lot of us miss it at this point. We want to start coding immediately, so we jump into PHP, Python, and Java and the rest. We don't take time to understand the whole internet technology, how it works. For example, the first topic here is how the internet works. You need to understand how the internet works. For me, what I'm going to recommend here is that you learn something called the OSI model. That's the Open Systems Intercommunication. I hope I got it right. OSI model. Learn the OSI model. The OSI model is this model, theoretical network stack model that has 7 different parts. You have the application layer, you have the session layer, you have the presentation layer. This is where your application operates, how your application sends payload down. And next is the transport layer. This is where your protocols like TCP and UDP help transfer data from one application to another. And also down to the network layer, from the transport layer, that's where your TCP and UDP operates. Then to the network layer, where you have your IP, that's where you have your IP addresses. The combination of the IP addresses and the ports that operate in the transport layer is actually what you call a socket. So you can have a TCP socket for a TCP transmission, or a UDP socket. Then from the IP, that's the network layer, you go down to the data link layer. That's where you have the MAC addresses, and up to the physical layer where your bits and bytes go over the wire. That's where you have your devices, your physical devices. That's actually the physical part of the OSI model. So you want to understand concepts like that, and if you have time, you can go as far as learning the core routers that control the internet, the different autonomous zones, and how the BGP protocol makes sure that packets get from one destination to another as fast as possible. So yeah, you want to understand how the internet works. I have a book here that I recommend. It's literally named How the Internet Really Works. So you can check out this book. It's a very, very easy book to read because it has all these pictures that explain very common internet concepts. So if you're interested, you can get this book. It's very, very useful to just get that holistic knowledge as to how the internet works. Then you have HTTP. As a backend developer, you're going to be developing a lot of APIs. We are in the service-oriented architecture stage of development, web development. Most of the time, you have to write APIs for clients to communicate to. So you want to understand how HTTP works. This is where you learn things like HTTP messages, what consists of an HTTP message. That's your payload, your headers, You understand things like cookies, sessions. If you ever think you missed the class on cookies, sessions, and things like authentication and stuff, this is where it resides. HTTP. HTTP is the protocol of the web, so you have to take your time to understand the concept of HTTP if you're going to be building any API that clients are going to consume. I will also recommend an HTTP book. This book, HTTP The Definitive Guide by O'Reilly, you can see how thick it is to tell you how serious the HTTP topic is. So yeah, HTTP The Definitive Guide, that's what I'm going to recommend for you. If these two, how the internet works and HTTP, they are very core fundamental concepts to developing web applications. I also mentioned it in the front-end developer roadmap. These are core to whatever you're going to be doing as a backend developer. Next is how browsers work. This might be more important to front-end developers than backend developers, but yeah, like I mentioned when I was talking about HTTP, you have HTTP headers, and HTTP headers are how the client and the server communicate. So you have to be able to understand these concepts and how the browser sends headers to the server in order to communicate with the client. For example, cache headers, authentication headers, authorization headers, and the likes. So if you understand how the browser works, how the browser sends these headers, there are even some small differences between browsers, but most of them are encapsulated now and most of them are standardized now. But you want to understand how browsers work in order to know how to communicate with the browser. When a browser sends a request, in the response headers, you also know what to send back. For example, in operations like content negotiation, when you're trying to when the browser is asking you whether you have JSON or XML and giving priority to either of them. Okay, if you have JSON, give it to me, but if you don't have JSON, give me XML. So that's one of the reasons why you want to understand how browsers work, because browsers are going to be your main client. They're going to be your most important client when you are developing a backend application or an API that the client is supposed to consume. They are the most common APIs, and understanding how they work, how they send headers is very, very key to responding in the appropriate way to your client. The next is DNS, domain name service, and how it works. DNS is how you see, we as humans, we don't use numbers on the web. Computers understand numbers, but we humans, we understand names. So when you want to go to a website like facebook.com, we don't expect that human beings will remember the IP of facebook.com, because we have so many domains that we want to visit. So the DNS protocol helps convert a name into an IP address. So when you type something like facebook.com into your web browser URL, yeah, it query the DNS server, and the DNS server returns an IP address, and that is what is actually where the request is actually sent to. So that's DNS. So you learn DNS and how it works, the different types of DNS records, like the A record for the IP address, that's the IPv4 address, the quad A record, that's the AAA record for IPv6 address, MX records for email, and there's also TXT records where you can just dump anything. Yeah. So yeah, DNS and how it works, quite important, because you're going to be hosting your application. So you want to really understand how DNS works and how to get a domain name and host your application. What is the domain name? Like I said, computers work with numbers, but humans work with names. So a domain name is what humans work with, like facebook.com, like twitter.com. That's what you type into your web URL, and that resolves to an IP address. So you want to know what a domain name is, the different types of server that can be in a domain name, like a web server, like an email server, and like an FTP server. So yeah, you want to understand what the whole concept of domain names, and also what is hosting. Like I said, you will be hosting your backend applications, so you want to know how to host, how to provision a server, and how to connect that server to a domain name so that your clients can call your backend services. So that's everything about the internet. Like I said, this is the foundation of everything you'll be doing as a backend developer, and most of us skip this because we want to jump straight to coding. But I would advise you, start with this. Start with this. Make sure you understand how the internet works. Then you can start writing applications for the web. So next on the list is picking a programming language, learning a language. Now, some of these languages are newer than when people like us started. I've been developing applications for over 10 years now, so some of these languages didn't exist then. So we have Rust, we have Go, we have Java, JavaScript, Python, C#, PHP, and Ruby. Now, the roadmap.sh guys, they didn't mark any one of these purple, and I But I want to guess they want to stay out of the whole programming language arguments. So yeah, everybody's very very sensitive about their programming languages. So I'm sure they are trying not to ruffle any feathers here. So we have Rust. Rust is one of the newer languages. Rust and Go. I started with PHP, which I still love. I PHP is just awesome. So yeah, I'm going to be a PHP fanboy for life. So I started with PHP. I there was yeah Ruby. There was a time Ruby was looking like it was going to take over. I think that was like 2016, 17 or so. I don't know. Yeah, I don't know for sure, but around that period 15, 16, 17, Ruby was looking like it was going to take over, and everybody was just saying Ruby on, it was just on the Ruby on Rails train. So yeah, it was sad that it just fizzled out. The popularity isn't as much as it was back then, but then Ruby was a big deal. Ruby on Rails was on everybody's lips. So like I said, I started with PHP, which is still fantastic till now. Laravel even made PHP much more popular. C Sharp, that's Microsoft. Java, one of the, if not the most popular programming language. That's if it has not been kicked behind by JavaScript. I write JavaScript mainly today. Everything JavaScript. I write JavaScript in the front end, the back end, everywhere. I write JavaScript. So that would be my own personal pick. But like I said, feel free to pick anyone. But if I'm going to advise, if you're a beginner, you want to pick something around PHP, Python, and JavaScript. Yeah, you want to pick something around PHP, Python, and JavaScript. It has a quicker time to value than the other guys. So they are easier to learn and you can quickly do stuff. And I'm going to say all these programming languages can get you what you want. Almost all of them can get you what you want. So you just pick one that you flow with, the one you understand the most. And the most important thing is understanding the programming language to a to like 80% level. I see a lot of people arguing about programming languages today, and people say, oh yeah, I can write 5 languages, I can write 4 languages. That won't really matter if you are not really good at these languages. Do you know how to write tests in this language? Do you know how to use all the standard library of this language? Do you know how to write performance code in this library, in this programming languages? That's all that matter at the end of the day. So whichever one you pick is fine. I've written C# before. I wrote Python for my university courses and stuff, and at the end of the day, writing JavaScript today, I can do everything with JavaScript and I'm at peace there. And that doesn't mean that people writing Python or writing PHP or writing Java don't know what they're doing. So but for a beginner, I would advise that you want to start with something like PHP, Python, and JavaScript, especially when you want to start doing things in time. Languages like Rust and Go require a lot of fundamental knowledge. They take a lot of time, not in terms of their speed rather, but the learning curve is kind of steep. It's steeper compared to languages like PHP, Python, and JavaScript. Java is also heavily object oriented, so before you approach Java, you want to be very very sound in object oriented programming. So that's why I said, compared to PHP, Python, and JavaScript, the other languages have, and Ruby, yeah, Ruby is also easy to learn. The other languages are steeper, their learning curve is steeper. So, but if you have time and you love any language you love, just pick it and start writing. But like I said, don't get into arguments about which language is better, which language is faster, or stuff like that. Just pick a language of your choice and learn it well, and be able to do those things that I mentioned. Be able to write performance code, be able to write tests, be able to understand a large part of the standard library, and just be awesome at doing it. So yeah. Then after picking a language, we then go to version control systems. If you're going to be working in a team, you need a version control systems. Version control systems allow you to version your code, so you can have different branches of your code. You can share your code. You can push your code to repo hosting services like GitHub, GitLab, and Bitbucket. So version control systems help you work within a team, and a lot of people, especially self-taught developers like me, we skipped it. I skipped it, and the first time I worked in a team, that was around 2015, I think. That was when I realized how important it was, because I was just zipping up my code in zip files and sending them through email and stuff, which was terrible. Hosting some of my code with FTP servers. But when I had to work in a team, I realized that how important Git was, and you don't even need to learn, like, you don't even need to learn Git in depth. There are like 5 or 6 major commands that once you know them, you'll be able to do most of what anybody using Git will be able to do. Things like Git add, Git merge, Git checkout, Git commit. Yeah, once you know like all those 5 or 6 commands, you'll be able to do a whole lot of what you require something like Git for, a version control system like Git for. There used to be a time there was one called Mercurial. I think probably it still exists, but Git is the clear winner when it comes to version control systems, but Git is used locally. You can only use Git locally. For you to use things like GitHub and stuff, you have to have an account with a repo hosting service. Repo hosting services, GitHub, GitLab, Bitbucket. These allow you to push your code to their servers, and others can, clone your code, and you can collaborate in the cloud. So yeah, GitHub is a very, very popular choice. I have experience with GitLab and Bitbucket also, especially in enterprise environments. But yeah, GitHub is the most popular amongst the 3. So yeah, repo hosting services. And yeah, next is going to be operating system knowledge. So the next step is understanding OS, that's the operating system, and general operating system knowledge. First, you want to start with some basic terminal commands. You need to know how to use the terminal if you're a backend developer, because it's not every time you're going to work in environments where you have a GUI. So the terminal is like the most basic form of entry to any computer system. So you want to know how to use the terminal. Now, I notice most of the commands here are Linux commands, so you probably want to learn the Windows equivalent of this. These are Linux, Unix commands. So for example, like grep, which is used to search like a phrase in a bunch of text. We have things like tail, which you can use to read the bottom part of a particular file. Head with the top part. Less, read step by step in little chunks. There's a find command. There's the SSH command, which you use to remotely connect to other systems using the IP address and the login credentials. And you have the kill, which I believe, yeah, is for killing a process. And dig is for DNS. Yeah, dig is a DNS command. Yeah, correct me if I'm wrong, but yeah, I think dig is a DNS command. Then let's go up a little bit, since we're still talking about command line usage. You see, you need to understand how to use the terminal. POSIX basics. I think POSIX means portable operating system interface. Yeah, so the standard in, standard out, standard error, these are data streams. And you have pipes, so they're basically streams. So you have the standard in, the standard out, standard error, that's the error stream, and pipes. So these pipes is what allows us to pipe commands. Like this type of commands, you can pipe them in Linux or Unix systems, and I believe Windows too. So yeah, you just want to understand how to use the operating system. Yeah, that is very, very important. But like it is marked there, they are important. These are important for you to learn. These commands, you can learn them anytime, but they will make your life a lot easier, especially when you have to work with servers or you are doing a lot of CI/CD scripting and stuff like that. You want to be very, very familiar with this type of commands. Now to the concepts themselves, now the OS concepts. You want to understand how operating systems work in general, how the operating system virtualizes the hardware, and you have user land apps being run by the operating system. So the operating system gives them their memory, it gives them their disk space and stuff like that. It gives them, it passes their instructions to the CPU to run their instructions. So you want to understand operating systems in general. There's this very good operating system book that I got. It actually summarizes operating systems into 3 different functions. There's virtualization, concurrency, that's the ability to run apps, like 3 apps at the same time or 5 apps at the same time, ability to run multiple apps at the same time. So we have virtualization, which is what I just explained, the fact that programs are turned into processes, and each process has its own memory, and it is also served to the CPU and stuff like that. So and the third is persistence. So this book, Operating Systems, the 3 easy pieces, that's the book I'm talking about. It's a very complete book when it comes to understanding how operating systems work. But any other operating system book, that is, there are a lot of other good operating system books that you can get, but this one is is special. I've been able to learn a lot about operating systems from this book. By the way, all the books I've been recommending so far, you can see the link in the description. So in case you're wondering where to get them, all the links are in the description. Also, you want to understand memory management. Yeah, memory is a very, very limited resource in the system, and the operating system also virtualizes the memory. So what your applications are actually using is virtual memory. So there's an MTU, no, not an MTU. There's a memory managing. Yeah, there's something in the operating system that manages memory, that does all the memory management. I don't know whether it's called MTU or something. So yeah, memory management, how memory is allocated to your applications, that your processes, how memory is cleaned up, garbage collection and stuff. So you want to understand those type of concepts. I remember when I used to run into some database issues, database errors, and I didn't even know that it was a memory problem. My API would just go silent. I will call the API and nothing will be returned, no errors, nobody, and I can't even trace any error. It was later I realized that I was running out of memory. I was querying too many records, more records than the allocated memory can handle, and I would have spent a lot of time debugging that if I had understood what memory management was all about. You also want to learn about interprocess communication, how two processes can communicate by opening an IPC channel. That's the IPC, interprocess communication channel. Yeah. So interprocess communication, IO management. Yeah, IO management, very, very important. Input, output, basic networking concepts. Like I said, if you can understand the OSI layer, it will be fantastic. The OSI, the old OSI systems, or at least TCP/IP. Try and understand those concepts. You can go as far as understanding how routers work, how switches work, and stuff like that. But the OSI model is going to give you a lot when it comes to the theoretical concepts that surround how network works. Then threads and concurrency. Every CPU core has I think 2 threads. So and that allows us to run parallel tasks. So you want to understand what this is all about. Multi-threading. Concurrency is the ability of 2 tasks to run in parallel. So you want 2 or more tasks to run in parallel. So you want to understand this kind of concept, how the operating system manages those type of tasks, since the CPU does one thing at a time. So with multiple cores, and with these multiple cores having more than 1 threads, you can take advantage of these multiple threads and run multiple tasks concurrently. Process management, when your program is initiated, when your program boots up, it turns into a process. When it's in that environment that the operating system gives it, with its own memory and CPU allocation, it becomes a process, and you want to learn how to start a process, kill a process, or put a process to the background, or bring it to the foreground. So all about process management, operating system knowledge, very, very critical. A lot of people like me that didn't study computer science had issues with all these type of concepts when we were trying to develop applications. We run into a lot of errors. We don't know that they are caused by this basic concepts of computer science, even things like locks, that's mutex stuff. So yeah, it would be very important to learn these concepts as they have marked. They are also marked gray, so you can do it later, but I would advise, based on a lot of bugs that have wasted my time and have frustrated me, that you get this knowledge as soon as possible. I'm a books guy. That's one thing you have to realize. So I'm going to be showing you a lot of books throughout this. So I'm sorry about that, but I'm going to be showing you a lot of books to help you with this. And the book that I got that helped me with these computer concepts is this book. I love this publishers, these No Such Press guys. Their authors are just awesome. They explain things in very, very comprehensive manner. So how computers really work. That is the book that taught me everything I needed to know about computer concepts, at least to the level of a developer. I'm not a computer science guy, so I don't want I don't want the entire PBS special. So these books gives you just what you need. It's also one of the books in my 5 books every web developer needs to read. So you want to check that video out. This is also one. I think this is even the first book on that list. So yeah, operating system knowledge. I think we're done with that. Yeah, operating system knowledge. We're done with that, and we can move ahead. So the next thing on our list is relational databases. Now, relational databases are the type of databases you use the most as a backend developer, because they are perfect for transactions, and a lot of the data operations that are going on that you would work on as a backend developer are transactional data. So yeah, relational databases are going to be a very, very big part of your journey as a backend developer. So here we have Postgres, we have MySQL, MariaDB, which is, I think MariaDB is the open source version of MySQL, I think. But MySQL and MariaDB are basically like the same thing. It's just vendor differences. MSSQL, that's Microsoft, and Oracle. I think the only, yeah, I've used all these databases. I've used all these databases, but I primarily used MySQL for production. Every single time I've ever used a relational database in production environment, I've used MySQL for some reason. The time I got to use MSSQL, I wasn't in charge of the database. I wasn't even in charge of the backend. I was leading the front end team, and they were running the backend on C Sharp and using MSSQL because it's Microsoft. But all my production work has been in MySQL. Postgres, I use Postgres for a couple of tutorials, but I hear a lot of good stuff about it, and it's even recommended here. And so I hear a lot of like great praise for Postgres. But none of these are bad choices. Some are just heavy, like MSSQL and Oracle, very heavy databases in terms of installation and getting everything all set up. But MariaDB, MySQL, Postgres, can easily set it up on your system. They are lightweight compared to the last two. So yeah, relational databases, and you have to be logged in your SQL. Yeah, your SQL game has to be like tight. A lot of us, we learn, just like we trivialize CSS, we trivialize SQL a lot. We just learn a few commands and we're good. But what will help you to get the best out of your database is knowing how to query it correctly. And that's why you have to ensure that your SQL is top notch. You can get a book on SQL. I used to have a MySQL book. It's in PDF. It's like almost 1,000 pages. Almost 1,000 pages. Like so many queries to learn. Your DDL, data definition language, I think DML, data modeling language. I can't remember the specific names of those categories of SQL statements. But one thing they didn't mention here that I'm mentioning now is that what will help you to get the best out of these databases is to learn SQL and learn it to a professional level. And I will advise, get a book or a very standard video course. I learned better with books, so that's why I recommend books most of the time. I'm sorry I don't have an SQL book here, but that is one advice I'm going to give you. It's not about knowing these databases. They all have variances in the kind of features that they support, but all of them support SQL. And if you're very, very good in SQL, you will be able to get the best out of these databases. Next, let's go to NoSQL databases. NoSQL databases. Now, this came and they were very, very interesting because if you have worked with relational databases for a while, you will notice a lot of frustrations, especially with the shape of your data. And NoSQL databases just told us, you know what, forget the schemas, just structure your database anywhere you want. And a lot of people went crazy. Even though that time, a lot of us didn't take time to learn the gotchas and the quirks that come with NoSQL databases, because every database type has its limitations. Now, NoSQL databases are very, very powerful, and they brought about a lot of flexibility. They brought about a lot of flexibility to how we shape and undo data. There are different types. There's the document DBs, which are the ones that allow you to store records in JSON-like objects. So we have under that we have MongoDB, which I've used heavily. I'm a Node guy, so definitely MongoDB is like my best friend when it comes to NoSQL databases. We also have CouchDB. I haven't used CouchDB before, but I believe it's also equally good. But MongoDB, awesome. Next, we have time series NoSQL databases. These allow you to record data points against timestamps. For example, there was a time I was creating this I was writing this ride sharing application, and I needed to plot the graph of the path that each vehicle took for every trip. And for that, I was recording their coordinates at different points in time. But I didn't know what a time series database was, and I was using a relational database for that kind of thing, which made it very, very difficult. And as you can all understand, that wasn't the best strategy. So time series database helps you to do such kind of things. You can record different type of data points against timestamps. For example, let's say in a monitoring tool, you want to record the total requests per second at every single minute. You want to maybe record the number of queries to a particular database at intervals of minutes or hours, or time series helps you do that. So if you have any type of data you want to store against time series databases like InfluxDB, which I've used, and Timescale, which I haven't used, can help you achieve that. Then we have real-time databases, real-time NoSQL databases. These allow you to get updates in real time when you perform updates, or rather when you perform changes to your data. Probably you create new data or you update a particular data. You don't need to requery the data to get the update. It just updates in real time. It has this real-time socket connection with your front end, so that whenever anything changes, it reflects automatically. You don't have to perform the updates yourself in the UI. So yeah, Firebase, I use Firebase heavily. I use it for mobile applications. I use it for real-time stuff in desktop applications. I remember the last time I used it for a notification system. So yeah, Firebase, awesome. I've been using Firebase even before Google bought it. So Firebase is just amazing, and now they've even grown to be this very, very big suite. So there's so much to Firebase than we were even enjoying then, and it was already awesome as at then. RethinkDB, I haven't used it before. Then we have column DBs. Column DBs, these are an interesting type because they are most useful for big data analysis. You know, when you just want to dump a bunch of data somewhere and you want to store them in a way that it's easy to query, that's when you need a column DB. With relational database, you save data in rows. So for example, if I'm to represent a person and I'm to save the name, the address, the age, I'm going to save it in a row. But with column DBs just have, like, you know, all addresses in one column, all names in one column. So if you want to query all the names, it's very easy to just pick that column and you have everybody's names. You don't have to go row by row. So it's faster to query, and that's why it's a best choice when it comes to doing data mining and big data analysis and stuff like that, BI stuff. Then we have key value databases. Those are just for you to store very small key value pairs, mostly using caching. That's why you have Redis here. You just want to store just a single line of data or just a single object. That's why you have key value databases. So DynamoDB, Redis, awesome for that. Then we have graph DBs, which really caught my attention when I read about them, because one problem I used to face with relational databases is the whole relationship thing. You know, you have your foreign key, primary key, and you're trying to build this very complex relationship and stuff. Graph DBs help you do that. Graph DBs are built for building relationships between entities. So you have these nodes, and you have what they call, I think, edges. Yeah, edges are the properties between them. So in a scenario whereby you want to do something like this, you want to say, okay, how many women living in London are software developers? And how many men living in London are software developers? Then how many of those men are backend developers? How many of those women are UI UX? You know, those kind of complex relationships. That is what graph DBs, they create this relationship graph, and it makes it easy to query. You can simply say, yeah, I want the number of women under the age of 45 living in the UK and doing backend and backend engineers, and it would quickly get those results for you because the database is built to manage relationships between entities. Entities are things like people, jobs, age, skill set, and stuff like that. So yeah, graph DBs, awesome DBs, all these NoSQL databases are awesome, and they have come to solve a lot of problems that we're having in relational databases. Because before, you just have to do everything with relational databases, but now we have NoSQL databases, and we even have them specialized for different use cases. So on to more database concepts. First, we have the ORMs. ORMs are useful in OOP architectures. They help you map your classes to database columns and stuff. So they're like the bridge between your classes, your class definitions, and your database schema. So and with these ORM wrappers, they come with a lot of features out of the box. For example, a lot of querying functions that you can easily use to query data from your database without having to write SQL. So yeah, ORMs, very portable, very awesome for connecting your classes to your schema. Then we have ACID. ACID is I know atomic. A stands for atomic. Then C. Let's just check it out. Let me not mess up here. Atomic consistency. Then there is yeah, there are four properties: isolation and durability. Yeah, atomicity, meaning that every operation should be able to exist as its own, and if a group of operations are supposed to all uh, succeed, they have to succeed together. If they are to fail, they are to fail together. So second, we have consistency, meaning that data has to be consistent all throughout your database. Isolation and durability, meaning that stuff like database faults, like network failures and stuff, should not cause data to be lost in your database. So yeah, ACID principles are core principles of relational databases, and you need to be familiar with them. But they're basically things that your database is going to support. You just need to know how to make use of the ones that are required for you to pay attention to. That's atomicity and consistency. Durability is handled by your database, relational database management system. You don't have to manage that yourself. Yeah, so, but atomicity and consistency, they provide features to make sure that you achieve those two, but it's all in your hand. So however you manage it, it's all in your hand. So we have ACID. Make sure that your database is ACID compliant. Then transactions. Yeah, transactions. Like I said, one major thing you have to know about transactions is that if you have 5 operations that need to succeed, they have to all succeed. And if one of them fails, every one of them should fail. Every single one of them should fail, so that you can maintain that consistency with your data. Your data can remain, you can have integrity. You can maintain your data integrity. So yeah, transactions. So a database transaction is a sequence of multiple operations performed in a database and all served as a single logical unit of work. So, for example, I think everything is better with an example. Let's say you are to debit a particular customer and credit the other customer. That's a single unit of work. One customer is being debited because they're transferring money to another customer. Customer A is being debited to transfer money to customer B. Now, one of those two operations must not fail. If any one of them fails, 2 of them should fail. Or 2 of them should succeed. So it's an all or nothing rule. So that's the mindset that relational databases want you to have with transactions, and to make sure that you keep them consistent that way. N+1 problems. This is an algorithmic problem. Normalization. Yeah, normalization. They are also there for you to reduce redundancy in your databases, and also to maintain your database integrity. I think there's first, second, third normal form. Yeah, I stopped caring after third normal forms because they're just, I think there's a 6th normal form now. So I stopped caring after 3. I lost the interest in it. So yeah, these are rules that help you to remove redundant data, reduce redundancy in your database data, and also maintain database integrity. Then we have failure modes. There are different type of failures that can affect your database, things like disk failures, things like network failures and stuff. So you want to understand these failures also and know how to protect yourself against them. And you also want to know how to profile the performance of your database, see how fast your queries are running, and know how to optimize your queries. So yeah, these are other database concepts that you can learn, and to help you have that complete knowledge about databases. So after that, we have scaling databases. Yeah, you have to learn how to scale your databases. It's not only web servers that you can scale your databases. The first thing you want to do is to make sure that you write good indexes, the good database indexes. This will help speed up your queries. So yeah, that's the first thing you want to do. Then on a much higher level, you want to understand data replication. This is when you have like a database cluster. So there's a main database and there are these replicas. Then you maintain a commit log. So the main database is the one that receives all the updates directly. Then all the updates are written to the commit log so that the other replicas can asynchronously update themselves separately. So they lag. There's a small lag between the replicas and the main database, but the commit log makes sure that every single replica is updated to the same state as the main database, so that when the main database goes down, one of the replicas can replace the database. So you want to understand database replication, how that is done. Sharding strategies. This is when you divide or break down your data into different sets. These sets can be divided. These sets can be according to indexes, hash values, names. For example, let me just give an example to make that clearer. For example, let's say we want to store the name of you. We want to store users. We want to store user data, and we know that we are going to be having a lot of users, and we don't want to put that burden on just one database. We want to shard the database. We want different instances of databases where we put different sets of that complete data. So we can say, okay, every name that starts from A to F is going to be in this particular database. Then every name that stands from G to, let's say, Q is in this database, and so on and so forth. So that's one way you can shard your database. You can break it down into different sets so that you don't burden a single database instance with all that data. Yeah, so that's how you shard this. There's some issues that can come with that, because there's this thing called the celebrity problem, which is when you have more names starting with A than any other name. So you just keep having more of the data being stored in the A to F database, and that can constitute a problem also. So, but that's that also has its solutions, and but that's sharding. Yeah, sharding is different from replication, where you have the same data copied across different instances. This one is different sets of data copied across different instances to break down the volume of data that goes into every database instance. Then you also have the CAP theorem. CAP is consistency, availability, and persistence. And the theorem simply states that there's no single database that supports the three. Different database vendors are going to try to convince you that they support them in some sort of way, but the base rule is that no database can support being strongly consistent, because there's eventual consistency. No database can say it's strongly consistent, always available, and can be partitioned. So you are either consistent and highly available, strongly consistent and highly available, and you can be partitioned, or you are strongly consistent and you can be partitioned. You can't have all three. So that is the CAP theorem of databases. And all these concepts, indexes, replication, sharding strategies, CAP theorem, they all help you scale your databases. So the next topic is learning about APIs. Like I said, as a backend developer, developing APIs are going to be like your everyday work. So you have to, everything you're doing, everything you're building is to serve an API endpoint that clients can consume, at least right now in the world of backend development, today. So we have learning about APIs, ATOs and Open API specs. These are just different specifications and styles of structuring your API. I don't even know what ATOAS. I don't even know what that stands for. It's an acronym for Hypermedia as the engine of application state. Yeah, some sort of concept that when sending information over a RESTful API, the document received should contain everything the client needs in order to pass the data. Yeah, like I said, there's so many standards, it's even difficult to keep up with them. Open API specs, but like they've been marked. These are things that you can learn later. They're not going to hurt your you're not going to hurt your progress as a backend developer. You can always learn them later, or if your company needs it. Yeah, like one time when I had to learn, I had to do a lot of Azure, Active Directory. Yeah, I had to learn Active Directory a lot, like almost become an Active Directory expert just because my firm needed it. But one very important one is authentication. Yeah, API authentication. APIs are so open, so security is a big deal when it comes to API, and you want to be able to implement the correct authentication strategy so that unwanted clients will not be able to access your API. So we have, let's deal with the purple ones first. Those are the recommended ones. OAuth, basic auth. Basic auth is the, like name suggests, the basic authentication scheme that came with the HTTP protocol. That's also one of the things you're going to learn in this HTTP book. Basic authentication, digest authentication, which is like a more advanced version of basic authentication. Token auth, which is like the de facto these days for APIs. We are all doing token authentication for APIs, and the most popular type of token authentication is JWT, JWT, JavaScript Web Tokens, or is it JSON Web Tokens? Yeah, JSON, JSON Web Token. So yeah, JSON Web Tokens, and you also have other ones like OpenID. That's when you use an identity provider like Microsoft or Okta to authenticate people into your app, so that they can have access to your application by using a third-party identity provider. SAML, cookie based. Yeah, you can check those ones out. Also, let's go back up. APIs, back to APIs. The next another thing you want to learn is REST. Yeah, REST. Learn, rest, and be at rest. I don't know if that makes sense. Anyway, so yeah, REST. Let me see if I can remember. Representational state transfer. Let me see if I got that. Yep, I did. Representational state transfer. That is the most popular style of API architecture. So that's what gives back to the standard method: post, get, put, delete, and also how we structure our endpoints. So yeah, REST, representation state transfer, JSON APIs. You're most likely going to be communicating with JSON. Nobody uses XML like that these days. So yeah, JavaScript, JSON. Yeah, I think JSON or JavaScript object notification. Okay, JSON APIs. Yeah. Then not SOAP, not SOAP. Yeah, SOAP used to be this very old school. Um, I think it was similar to like an RPC style way of communicating with an API. And I remember my experience with SOAP, trying to implement SOAP in PHP, not implement SOAP, use SOAP in PHP. Then I was integrating a payment gateway. That was before the times of their Paystack and Stripe and stuff. And the payment gateway only supported SOAP, and it was hell. It was hell dealing with SOAP, and I'm glad it was great, giving a great check mark here, because, yeah, I hope you don't have to deal with a legacy system where you have to use SOAP, but I'm not going to be guilty of hitting on SOAP like this, because it's very, very difficult to use. It can be quite difficult to use, but yeah, it existed then, and it solved a lot of problems. But with the advent of REST, yeah, you can just throw SOAP over the fence. Then we have the gRPC, remote procedure call. I think the G stands for Google, which is kind of bold. Yeah, G yeah, it's a Google framework, gRPC. This allows you to just call functions directly instead of calling an endpoint. So anything RPC allows you to call procedures. Procedures are like functions. They're just functions. So instead of calling an API that then is mapped to a function, like a controller function, you can just call the function directly and pass your arguments. So yeah, gRPC, it's faster than REST. So I think that's its major selling point, because it's all new and shiny. But yeah, gRPC is really cool. I haven't really used it before, so that is why I'm not saying so much about it. But yeah, GraphQL. Yeah, GraphQL, wonderful. I love GraphQL, even though I would say it's not taking off as much as I expected it to, but it's still popular, and it helps you to have one single endpoint. So unlike REST, where you have multiple endpoints, you only have one single endpoint with GraphQL, and you query it as if you're writing an SQL statement, not syntactically though, but you tell, okay, yeah, I want this for this particular set of data. I want the name, I want the address, and I want the, let's say, sex, gender. So yeah, you can just define what you want in a set of data, and it will only return those properties in the collection of data. Or if it is a single data that you are looking for, it will only return the properties that you query. So it brought about this sort of query language for the front end to query data from the back end, instead of REST that just gives you everything. Or you use like let's say what do you call these things? URL parameters, query parameters to filter stuff. No, with GraphQL, you just define the query in the front end, and it gives you exactly the shape of data that you queried. So yeah, GraphQL is really cool. Facebook developed it to solve some problems internally, and I think that's probably why it's not so widespread, because Facebook is a big company, and most of us don't have Facebook problems. So you might not see the big reason why you have to dump REST and use GraphQL. So yeah, but GraphQL is awesome, and you can use it at any level, whether for a small problem or a big problem. It's just another direction when it comes to developing APIs. So yes, that is, I think that's all for APIs. Yeah, that's all for APIs. So we can move on. So next we have caching. So you can do client-side caching. That's what the one you can do with your cache control and caching, cache headers. That's the one that you send from your client request to the server, or from your server response to the client. Then we have server-side caching, which you can do with Redis or Memcached. Redis is one of the NoSQL databases that we discussed here. That's key value databases. And yeah, you can also use a CDN to speed up your or to cache some assets for speed, so that your stuff that don't change a lot can be loaded quickly, and you leave all the dynamic stuff to be refreshed. So yeah, caching, client side, server side, and the use of CDNs. Then we go to web security. Web security, which is another part that a lot of backend developers might skip. Your making your application secure is very, very critical, because there are so many ways to hack applications these days. There are so many security processes that are broken now, so you want to make sure that you're up to date when it comes to security for your web applications. So first, MD5, and why not to use it. MD5 is part of the hashing algorithms. These are hash functions, SHA, MD5, they're all hashing functions, but MD5 has been cryptographically broken. So any hashing function that you can reverse engineer has been cryptographically broken. So MD5s are no longer safe to use. I remember when I used to use MD5 to hash my passwords and save it in the database, but now you can't do that. So you want to use anything within the SHA family. Yeah, the SHA family, SHA-1, SHA-8, SHA-16. No, sorry, just joking. There's SHA-1, there's SHA-2, and I think there's SHA-256 and 512. 1 and 2 are broken already. Let me see if that information is here. So SHA-1 and SHA-2 have been broken, like you see. Oh, there's also SHA-0. Yeah, so SHA-0 is broken. SHA-1 has been broken since 2010. SHA-2 is this is an algorithm, but okay, yeah, SHA-2 is actually 256 and 512. So SHA-2 is SHA-256 and SHA-512. Those are the ones that are stable and currently widely used. Then I see there's SHA-3, which is the newest. So yeah, you want to use the SHA family for your hashing functions. Make sure that your libraries like bcrypt and scrypt are using this algorithm and not MD5. Yeah, stay away from MD5 completely. Then we have HTTPS. That's what you get when you install an SSL server, and it gets to encrypt your communication. That's your HTTP transactions from client to server. So even if somebody intercepts your HTTP traffic with like a tool like Wireshark, they won't be able to read the payload because it's all encrypted. So you do stuff over HTTPS. So OWASP risks. OWASP is Open Web Application Security. What's the P? Project. Open Web Application Security Project. Yeah. So what they do is that they keep you up to date with the risks on the web. They'll even have this yearly top 10 of vulnerabilities that you are to look out for and protect your applications against. Then we have CORS. CORS allows you to set up security for who can access your website. A lot of front-end developers don't have a good relationship with CORS, and it's because of back-end developers who are setting CORS rules. But CORS is a very, very strong framework for you to define who gets to have access to your web application. So knowing how to use it is very, very important. You set it with headers, headers on your endpoints or across your entire server. Then we have SSL TLS, which, yeah, HTTPS, SSL TLS, same thing. Then we have CSP. CSP is a content security protocol policy, content security policy. This was quite new at some point in time, and like I said, it prevents XSS, which is cross-site scripting, and clickjacking. So yeah, server security, I guess that's just all cybersecurity best practices in general. As you can see here, roadmap.sh has these API security best practices that you can look up. So that will be cool for you to check out. I'm also going to check it out, so I will most likely do a video on that too, because security is something I'm also very, very much invested in and interested in. I worked in a cybersecurity company for like 2 years, so yeah, security is a big deal. and I would also love to share a lot of stuff that I learned. So we have web security, and then let's go to testing. You want to write tests. I know we all have a lot of us have a very cold relationship with testing. A lot of us don't want to touch it. We just want to trust our code and push it, because why would I have to write code and write code to test code? Like, come on. But life has to be easier than that. But tests help you sleep at night. Tests add value to your applications by helping you remove bugs. Anytime you are writing a test, keep it in mind that you are removing a bug from your application. So if you look at it from that perspective, that will probably change your mind about writing tests, even though it's still cumbersome. And like I said in the front end video, now we have ChatGPT, so you can just allow ChatGPT to write your tests for you. Yeah, just don't put any sensitive information inside ChatGPT. They have warned. So we have integration testing. Integration testing tests the whole flow of your of a single process. For example, let's say a checkout process or a add to cart process. So processes like that often make use of different components, and you want to test the integration of all these components to make sure that that workflow is complete. So you write integration tests. We also have unit tests, which tests the components themselves, the unit functions, the unit components. That's what unit test does. And we also have functional testing, which is testing your application the way a user is going to use the application. Front-end developers use Cypress and stuff to do all this kind of stuff. So yeah, your tests, integration test, unit testing, functional testing. When you have thoroughly written tests, it will help you sleep at night. It will help you sleep well at night, because you know that you have affirmed that certain workflows, components, and your entire application is working as it should. So that would reduce the amount of times you get called at night to come and fix stuff. So yeah, that's test. Also, probably someday I'm going to do a series on testing. If you want me to, if you are very interested in that, please indicate in the comment section. Also, the fundamental concept that we talked about at the beginning, all the concept about DNS, the internet and stuff, if you want me to do videos on that, also indicate in the comment section. So next is CI/CD, continuous integration and continuous deployment or development. Now, if you're like me and you started hosting applications during the days of FTP servers, like they were the default to use FileZilla and stuff, or these Firefox plugins, FTP plugins, you will know how you appreciate CI/CD more. You're going to appreciate CI/CD more, because the kind of capability it has given us to just run a single command and deploy. Sometimes you even deploy to a staging environment, run tests before you deploy to a production environment. It's just awesome. I remember when I used to write down all the files I need to upload to an FTP server. I used to write every file that I've changed. I will write it down and upload them one by one to an FTP server. So you can imagine how many errors will go into that kind of manual process. So continuous integration, continuous development helps you to set up these pipelines that deploy your code to either a staging environment or a production environment. And for continuous integration, you get to run tests. Continuous integration is the side of CI/CD that runs tests, automated tests on your application. And when those tests pass, you then carry on to continuous development, where you then deploy to either a staging environment or a production environment. And oftentimes these two are connected, so that when tests pass, it can automatically be deployed, or deployed after somebody comes to approve it and it's live, it's GA, as they will say in product management terms. So yeah, that's CI/CD. So next we have software design and architecture. Now, I'm a sucker for architecture. I love everything architecture. So you want to learn about software architectures because you want to know how to structure your application, and it's best you work with best practices, architectures that people have tried and tested in very rigorous environment, under very pressure filled conditions and stuff. So you don't just want to design your own and be vulnerable to a lot of failures that you don't know about. So you want to use architectures. So you want to learn about design principles. For example, GOF, design patterns. That's Gang of Four, I think. Yeah, GOF is Gang of Four. So these are like the four guys that wrote, I believe, the first standard architecture book. So Gang of four people that wrote, because I'm not sure they're all, I can't remember their names, so I'm not sure if they're all guys, but I know 4 people wrote the very first standard architecture book, and they are mostly referred to as Gang of Four. That's GOF. So you want to study design patterns. Under that, domain-driven design. That's when you model your code according to the environment that you're designing for. For example, if I am going to design a procurement application, then I'll go and learn how procurement works and design my objects, my classes and stuff according to the processes within a procurement. For example, in procurement, I'll have something like an RFP or RFC class and stuff like that, a bill class and all that. So yeah, domain-driven design, your code mirrors the environment that you are developing for. Also, test-driven development, where you write the tests first before writing the code. So it's a test-first style of development, and it helps you to immediately inculcate the culture of testing into your development process before you even start the development itself. Then we have CQRS, which is quite popular, but I haven't really used it, so I'm not going to say much about that. Event sourcing. So these are different type of design and development principles that you can use for your applications, and sometimes you can have an hybrid. It's not for, you can have domain-driven design with a side of event sourcing, or like CQRS mixed with test-driven development. So it's not like you just go one way and you stick to that. You can actually just have an hybrid architecture within your application. So you have design principles. These are design principles, like design principles. Then there are architectural patterns. So we have design principles, which are like best practices. Then we have architectural patterns, which are, okay, how do you structure your application? And one of the most popular ones these days is microservices. So we have microservices where you have services dedicated to each kind of function. For example, you have like a notification service, you have a billing service, you have a let's say shopping service or delivery service and stuff like that. So first, we used to write what we were writing before, where we just have one application, but all those functions represented as code functions, like all those division of labor, all those activities. Let's say billing, you have delivery, you have payment. All those things, they are functions within our application, and we just pack them into one application. That's a monolith application. So we do that, and we have a database, we have a front end, so the end-tier applications. But with microservices, you split all that. It's called functional. It's a process called functional decomposition. So you split all those functions into different services, and you connect them with remote calls. So monolith apps, everything together in one code base, existing as functions. Microservices, functional decomposition. The functions become services, and you connect to them using remote calls or a messaging bus. So whichever side you choose to go with. So SOA, service-oriented architecture, serverless, which is just the fact that you don't have to worry about the servers. Not that servers don't exist, but you don't have to worry about the servers. Just write your code and forget about everything that has to do with provisioning a server or scaling a server. Just write your code and give it to a serverless service, and they will take care of all the server stuff for you. So you stay serverless in your mind. Also service mesh. And that's where you use service discovery, probably tools like Zookeeper and stuff like that. You have like a service mesh and a messaging bus. Anything that has different services spread around needs a messaging bus. You need some sort of communication system, probably like a pop-up system to connect them and send data across. Then we have 12-factor apps. Now, 12-factor apps are not apps in themselves. The 12-factor is just a bunch of rules that guides modern applications, things that they expect you to implement, or styles they expect you to follow in modern applications. Let's take a look at that. For example, there should be a single code base with multiple deployments. Dependencies should be declared, and you should isolate them from their dependencies, meaning that it should be decoupled from its dependencies. The configuration should be stored in the configuration environment. So you can have a different environment for staging. You can have a different configuration for staging. You can have a different configuration for production and development environments. Backend services should treat backend services as attached resources. That's just the same thing as decoupling them from the services that they depend on. Build, run, and release. That means you should implement CI/CD. Processes, the application should be executed as one or more stateless processes. Yeah, now this is quite important for horizontal scaling. When you want to scale something horizontally, you have to make sure that that application is stateless so that it can be replicated on multiple servers, and you can use a load balancer to distribute the workload, and all the instances can do the same thing, and they don't store data, so there's no data integrity complications and stuff. Port binding, you should expose the services through port binding, concurrency, disposability, dev prod parity. So you should have like a development environment, a staging environment, production environment and stuff. Logs, keep logs and treat them as streams. Yeah, pipe them into stuff like Elasticsearch or Splunk or Kafka. Yeah. Then admin processes. Yeah. So 12 factor apps, just best practices for modern applications. That's how to see them. Then we have search engines, and I'm kind of surprised why these are called search engines, because Elasticsearch is simply a log collection tool, ingestion tool, ingest logs. I think the Elasticsearch, it should be ELK, is an ELK stack. Elasticsearch, Logstash, and Kibana. So Logstash is the one that pulls the logs. Elasticsearch helps you query the logs, and Kibana allows you to visualize the logs. So yeah, probably these are search engines for logs, for application logs. Probably that's what they call them, search engines, but I don't know why they call them search engines. So, and next we look at message brokers, which I have a special interest in. So message brokers. So there was this time when I was developing applications and I knew nothing about queuing and message brokers, that my servers would just shut down because there's too many requests. They're bombarded with requests, and before you know it, all the finite resources on the server is burnt out. Things like memory is the main is the main culprit, burnt out. So for example, let's say your server can take 100 requests per second. Let's just say 100 requests per second or 1,000 requests per second. But then you start getting so many requests and it goes to 10,000 requests per second. That's something that needs to be queued. Especially if those requests don't need to be attended to immediately. For example, if you are blasting out 20,000 emails, but your email server can only handle 1,000 per second, and you just send 20,000 requests to it, that server is going to shut down. So what you want to do, you want to buffer the requests and serve it to your server at a rate that it can handle. So a message broker helps you to do that, and it adds this thing called asynchronous processing, meaning that stuff can actually wait and be served to the consumer at a rate that it can handle. So message brokers are a very, very interesting scalability tool, and the most popular open source versions, because they're Azure and AWS have their service offerings, but the most popular open source options are RabbitMQ and Kafka. The roadmap.sh people recommend RabbitMQ. Kafka is actually really, really powerful, even way more powerful than RabbitMQ. Even though RabbitMQ might seem easier to use, but that's just a relative thing. But these two are great. I would recommend Kafka if you can learn it, because Kafka is just really, really powerful. But it requires a lot of understanding of distributed systems, so you want to have that in mind. A lot of things that we've been discussing so far have been related to distributed systems. So if you hear things like these search engines, serverless, microservices, design principles, or this sharding, all those scalability principles like sharding, like horizontal scaling, load balancers and stuff, they're all about distributed systems. So if you want to get a good understanding of distributed systems, I have another book for you. It's been long I introduced the book. So you can get this book called Understanding Distributed Systems. It will help you understand a lot of these buzzwords that are flying around development these days. So yeah, that's another book for you. Like I told you, I'm a huge fan of reading books, so I'm going to be doing that a lot. There's also an architectural book. Yeah, if you want to study architectures, we just finished talking about architectures. You can check out this book, Fundamentals of Software Architecture. Yeah, there's so much architecture knowledge in this book. So you want to check it out if you are interested. So message brokers, RabbitMQ and Kafka, awesome stuff. Then containerization and virtualization. This is huge in today's world of microservices. serverless, service mesh and stuff. You want to put your applications in containers, have them as these isolated units, and be able to deploy them across different environments. So we have containerization with tools like Docker, LXC. I haven't used LXC before, but Docker, yeah, huge. And when you start working with so many containers, you need to be able to order them, you need to be able to coordinate them, basically orchestrate them. And one of the most popular orchestrating tools is Kubernetes. You want to use Kubernetes to guide your containers and provide services that your containers would need. So we have Kubernetes. There's also Docker Swarm, but Kubernetes is so popular. Many people, you might have not heard of Docker Swarm, but Docker also has Docker Swarm. Then GraphQL again. Wonder why? Apollo is one of the very huge GraphQL libraries that you can use. There's also this Relay Modern. I haven't heard of them, but I've heard of Apollo. Then WebSockets. I believe we're going into real-time stuff. So GraphQL isn't really real-time sort of, but WebSockets allow you to, create a real-time channel between your client and your backend. So yeah. Server-side events too, they are even native. I think they're native to the browser or the backend. But yeah, these are huge also. And even though they're not as popular as WebSockets, but they do something very similar to WebSockets. Then we have web servers. Web servers where your applications live. Popular ones are Nginx, which I love and use. There's also Apache, which has been around for a very long time and got to set a lot of standards that we know today with web servers. We also have Kadi. I haven't had or used Kadi before. Then Microsoft IIS, which is also really has been around for a very long time, just like Apache, and is available by default on all Windows systems. So we have web servers. And then lastly, building for scale. So to build for scale, this is where we have all our scalability styles, frameworks, and principles. Let's go to this side first. First, you want to understand all these monitoring concepts: instrumentation, monitoring, and telemetry. Instrumentation is where you set up the log metrics collection agents. A lot of monitoring tools like Prometheus, they have these agents that you install in your application. Libraries you had, some of them are agentless, so that's pretty cool. Some of them just require you calling an endpoint, maybe an else endpoint and stuff. But instrumentation has to do with all the things that you have to do to collect your metrics and logs, all the information you need from your application. Then monitoring is monitoring itself, your searching your logs, searching your metrics, visualizing your metrics, creating dashboards and stuff to measure things like, let's say, requests per second, latency, performance, and availability, health monitoring, and all those stuff. So then telemetry actually deals with how you use and combine your data. That's the data that you get, the type of intelligence you get from your data. So yeah, that's those three. Then we have these mitigation strategies, which I believe are fault tolerance, graceful degradation. That's when you build your application in a way whereby even if some components fail, your application can keep running. For example, when you do horizontal scaling and you load balance to 5 different consumers or 5 different servers, if 2 of them go down, your application can keep running. Or if a component in your application fails, you find a way to keep operating. Probably start buffering a request into a message broker while trying to get the server that just shut down back online and stuff like that. So yeah, graceful degradation, very important, because you don't want your application to just fail and nothing works. Then throttling is another strategy that is used when you have like a spike of requests, like we described the previous time. When you have too much requests than your server can handle, you can just throttle, that's slow down the requests. You can slow down the rate of request. Probably you're getting requests at 10,000 requests per second. You can slow that down to like 100 or 1,500, just to make sure that your server does not crash, especially if these are not high priority stuff, high priority work, probably like log collection or stuff like that. So you want to throttle. Also back pressure occurs also when you're getting when you have this connection pipeline and it's getting too much data than the consumer can handle, it starts to create this back pressure, just like in pipes. If you are passing too much water into a pipe than it can handle, you see the pipe starts to swell because there's back pressure. And before you know it, if you continue pumping water, that pipe is going to burst. So there are also strategies to deal with that, mitigation strategies to deal with that. Load shifting, which I believe is kind of like load balancing. Yeah, just distributing your load across multiple instances of your application. These days you don't have to just leave one instance out there fighting for its life trying to serve all your web requests. You can add a load balancer and you don't have multiple instances of your application, and that's why your application needs to be stateless. Multiple instances of your application, and the load balancer can spread the load across all these applications using different load balancing strategies like least weight, least time, least connection strategies, or just round robin. Then you have circuit breaker. I think this also allows you to fail over safely, so that let's say the circuit breaker design pattern is a way to protect a system from failures or excessive load by temporarily stopping certain operations if the system is deemed to be in a failed state. So I think this is where it says things like fail open, fail half open, and stuff like that. Yeah, closed, open, half open. Yeah. Not super familiar with it, but yeah. Then you have your migration strategies. If you want to migrate data from one application to another, or one type of database to another, different type of strategies for doing that. Types of scaling, horizontal scaling, like we've been saying so far. Vertical scaling, which is what you do by increasing resources. For example, one way to scale a server is by increasing the memory, increasing the disk size, or using a faster CPU. So that is vertical scaling. But horizontal scaling has to do with replicating workers and load balancing your load across them. Then we have let me not break my teeth. Observability, metrics logging, and other observable items that can help in debugging. Observability helps you to be responsive to issues within your application, so you monitor things that are important, actionable items, and you set thresholds, and when these thresholds are being passed, you get alerts and you get to act on them instead of waiting for the application to crash before you do something. So it's a way to be proactive about responding to faults within your infrastructure. And that's everything. There's some frequently asked questions here, and they recommend that you move to the DevOps roadmap next. Yeah, I'm going to check that out, and if I'm feeling solid, I would do that. I will do a video on that also. But that's that. You can read the frequently asked questions down here. Once again, big ups to roadmap.sh for these amazing roadmaps that they've helped me to use to give you this video. Like I said, if you want me to teach some of these topics, especially the fundamental ones like how internet works, how domain name works, or stuffs under the operating system and the likes, please indicate in the comment section, and I would, based on the request, I would work on those also. So thank you very much, and that's your backend developer roadmap. See you in a different video. If you have enjoyed this video, please leave a like and remember to subscribe to know when we drop more videos on this channel. Bye.